So the presentation today is very much a close collaboration between COPRI and UTAS. So Wong Sang, I think, is in his car between kids drop-off and pick-up. But Wong Sang, feel free to intervene. And so I'll be speaking for the first few slides, and then Peter will jump in towards the end. So this is picking up from the work that the team did 2 years ago on the Aron, and we had some first data, and we're now looking at expanding that work a bit further. So the research questions, we've already had a lot of wonderful introduction from Karen and Anna, so I won't go any further into that. But the main thing that for us, we have a physical oceanography team, obviously with COPRI, that Wong Sang is leading, that is very interested into the water masses and the pathway for those warm waters to get under the ice shelf, and where does that ocean-driven melt is occurring under the ice shelf. And from a BGC perspective, Pierre, Guillaume, and I are quite keen on looking at the subglacial meltwater content in iron as a fertilizer potentially of the waters near the ice shelves. So on the Antarctic surface waters, we want to look at whether the waters coming out are enriched in trace elements from glacial processes and whether they lead to greater production in the nearby polynyas. And potentially we could try to compare the data that Pierre obtained 2 years ago to what we get this upcoming season. So Pierre was meant to present this one, but I'll present it on his behalf. He's still working on the paper. So during the 2020 work, early 2020 work that the team did, you can see here the ship track with the chlorophyll concentration. So you can see higher concentrations in green. And then in red, you can see the incursions that the team did with the AUV. So they did 2 incursions. One AUV mission was within the Antarctic surface waters at about 50 meters deep. And then the second incursion, the A3 incursion here, was under sea ice, and they did about 30 kilometers under sea ice there at about 1,000 meters deep within the modified circumpolar deep water there. So from that data, Pierre is still working on it, but he's been looking at the meltwater fraction as well as the iron content in those waters. And what we can find is a significant correlation between the dissolved iron concentrations in the meltwater and the meltwater fraction, basically in those water masses, which is very interesting for us. He did manage to calculate as well the N members and how much the contribution of glacial meltwaters are bringing into the area. And he got a number that is about 5.5 nanomoles. To put that in perspective, it's a lot higher than what we have in Antarctic surface waters. It's usually about 0.1 or 0.2, and that's limiting for phytoplankton. But that's a lot lower than what we were expecting. And the conclusion at the moment of Pierre's work is that that iron is actually lower than expected because there's not enough ligands to keep it in solution. And ligands are basically organic molecules that are produced by phytoplankton and bacteria that help keep trace metals in solution. So Pierre is still working on that data, but looking at the 2019-2020 season, we'll have the same sensors as a couple of years ago. So the COPRI team is really interested in the sonar data that we're going to get some side scan, bathymetry, and sub-bottom profiling. CTDs, obviously, with DO and turbidity, and ADCP facing up and down, as well as the magnetometer. And Peter will come back to that a bit later. Our strength, I guess, on the AUV is the trace metal water sampler that Pierre's been developing over the last few years, which allows us to take water samples in areas where ships can't usually get to. So we can get about 20 samples of about 145 mil each, which is not a lot, but it's already quite a big advance for us. So with those, we take samples for trace metals, for flow cytometry. This year, we're going to be looking at ligands because that's our big ticket item, as well as nutrients and delta O18 to have an idea of the meltwater fraction. And Peter will come back to the obstacle avoidance setting for the under ice work in the coming slides. So the plans for us coming up this season, and we've seen, it was great to see what the other AUV teams were planning because we all seem to have similar goals and complementary skills and interests. Wongsang and our team are quite interested in going towards the western side of the Thwaites Glacier. So looking at areas that Anna was talking about before, the T2 and T3, noting that obviously those will depend on sea ice conditions at that time. We may not be able to access that area. Second option, if the sea ice is too tricky on that side, would be to go to the eastern side of the Thwaites Glacier to look, as the teams mentioned before, to look at the Pine Island Trough and the warm water intrusion under there. And if everything is blocked out around the Thwaites, we could try to go to the Pine Island, depending on sea ice conditions there as well. So we'll have to keep a close eye on that. Within the T2 area, we're quite interested in looking obviously at the inflow and outflow. For us, for BGC purposes, the outflow is super important and super interesting because that might contain a fair bit of iron that could then feed into surface productivity in the area. But we're also interested in looking at whether there's connections between the T3 and T2 area, possibly the inflow at in the Pine Island Trough, and whether these two areas are connected as well through the eastern ice shelf. So similar, I guess, interest to the other AUV teams in that area. Sea ice, I've been asking Guillaume to look at the sea ice conditions and look at climatologies. I should have asked him to zoom in a bit more like Karen presented a bit earlier, but we basically looked at the 1998 through 2017 to have a bit of an idea of how things are looking. The Amundsen Sea obviously has a lot less sea ice concentration. You can see here on the December through to March climatology, you can see the Amundsen Sea, the Pine Island Polynya has a fairly high sea ice concentration. The minimum is about 50% at the time of the cruise that we're aiming to go at. Compared to the Amundsen Sea, you can see that the sea ice concentrations are a lot more favorable to access in front of the ice shelves. So we'll see how we go. We'll keep a close eye on that. But even between here, the Pine Island and the Thwaites, the Pine Island seems to have longer open water duration compared to the Thwaites. So we'll play it by ear, I guess. So from a BGC perspective, a lot of the research that the other teams are interested in is highly, I guess, with the under ice shelf work is more on the physics and the glaciology, noting that there's also some BGC going on with Karen Haywood's team. But our main goal for our BGC team, and then Wongsang also has a fair bit of work on the physical oceanography side of things. We're really interested in looking whether enhanced ice fluxes and enhanced basal melts in the polynyas nearing ice shelves are translating into increased productivity. That's been a hypothesis that's been laid out for a few years, but we haven't been able to test it yet. So Guillaume who's going to be on board with us, he's been looking at total ice fluxes, both in the Pine Island polynya and the Amundsen Sea polynya, but this one is probably the one we're looking at more into where we're heading. You can see the total ice fluxes obviously going up. But the productivity in surface waters is actually not significantly correlated at all with increased ice fluxes. So it doesn't look like having more ice melt or ice flux into the ocean is actually translating into enhanced productivity. So what we're planning to do on the mission to test and further look at that hypothesis is obviously for the physical oceanography team, because they have similar I guess, upstream interest, and we're coming more in the downstream aspect of things. But we first want to track the MCDW that is getting inside the ice shelf cavity, and to quantify, in our case, the iron and the ligands that are in that water, and whether that signal intensifies as the water is moving more towards the ice shelf cavity, whether it's taking up more iron from the seafloor and more ligands. The COPRI team is highly interested, obviously, in the bathymetry and the sub-ice shelf bathymetry to see whether that's helping to get some warm water intrusion into the area and how that affects the ice shelf. Second, obviously, for us is we need end members for all of our fluxes, and the closer we can get to the grounding line, the higher the iron concentrations are going to be potentially. And we want to try to see whether we see differences between the subglacial outflow that may come out versus the basal melt rate versus any iron that is being brought up next to the grounding line. We don't know whether we're going to get that far, but it's always good to dream big. The next one, if it's coming on, we're also interested into sub-ice shelf or ice shelf properties to map the underside of the ice shelf, looking at surface roughness, as well as quantify, again, the BGC properties within that buoyant or sub-ice shelf current that is traveling along the base of the ice shelf. We won't have a full team for the BGC, but there's going to be a lot of physical oceanography work, which is great and will give us a lot of information. But from the CTD data, Guillaume and I will work on getting nutrients, chlorophyll, some flow cytometry, and associated biological parameters to have an idea of how these change, whether we are next to inflow, outflow of meltwaters. And finally, as far as sampling goes, we're trying to get as much data as we can. So when the AUV is out, or when we're not using the AUV or the CTD, we'll be doing some drone sampling. So Pierre and Guy have been working on trace metal water sampling from drones, and we'll be looking at taking some surface water samples in the ice shelf, next to the ice shelf front, in the lee of icebergs or near sea ice, to just complement the number of data that we're going to collect during the campaign. Looking at the staged campaign, so I'll pass over to Pete. We've been discussing this quite a bit, how to best approach the way that we're going to approach the ice shelf cavity and how we progress. And so I'll pass over to Pete to go through those.
Hey, thanks, Delphine. Yeah, so as I guess alluded to earlier, we're doing a very similar approach to 2 years ago, just adding another phase, but kind of a staged approach. So phase one is kind of going in as far as we can towards one of the primary goals, going towards one of the Copery borehole locations to see if we can't link from the open water in towards their borehole. We'll be focusing on what we're calling medium quality bathymetry. We have 2 bathymetric sensors on our vehicle. One, we can get pretty decent data at about 75 meters off the seafloor, which is a nice safe altitude for us to run. As Alex alluded to earlier, our experience from 2 years ago was that some of the bathymetry down there is pretty gnarly and can be quite difficult to track over. We'll be running ADCP facing down and taking water samples along the route in and out. This is kind of our bread and butter mission, probably will be one of the big focuses. We have our sub-bottom sensor, which is a long-range single beam. Normally has been used, obviously, to do penetration into sediments, but we've, on our previous 2 Antarctic missions, we've run it upwards because it's a very nice sonar for getting long-range ice draft. So if you're in somewhere with 1,000 to 1,500 meters of water column, even at the bottom, we can get a nice profile. And we got some pretty good data with that in our first year on our ice shelf at the Sourcewell. We were able to get some pretty nice profiles. On to the next one, Delphine. Phase 2, so looking at the data from phase 1, the kind of the bulk quality bathymetry, we may identify some areas where we can go in and do lower altitude missions with our higher resolution bathymetry and side scan to do some sort of spot checks and higher resolution survey areas. As well, we'll be collecting water samples, again, which will allow us to get water samples much closer to the seafloor, as well as ADCP much closer to the bottom. So getting into that kind of butter zone, a higher resolution ADCP as well. And again, our sub-bottom, once it's mounted upwards, stays upwards for all the missions, but our ADCPs, we can choose to fire up, down, or both. Kind of the gold standard, we try to go for things are going well, and our first 2 phases go really well. This year, we are looking at attempting doing some vertical profiling through the water column. This is something we did test earlier this year at our Trials Lake, which is a 200-meter deep freshwater lake we use. So our vehicle, using the upward DVL and our forward obstacle avoidance, we can detect ice above us. So focusing on the water sampling, the goal would be to go in underneath the ice cavity near the seafloor with DVL track, and then on the way out, do periodic ventures towards the ice surface, where we would detect the ice surface, grab a water sample, a block of data, return to the seafloor, and do a few of those. So colloquially within the group, we've been calling it the Toblerone, because that's sort of what the profile ends up looking like. So yeah, so that'll give us some vertical structure in the water, as well as hopefully some water samples much near the ice ocean boundary. EDCP facing up, we may be able to plateau at the top of the Toblerones to get periods of near ice ADCP data as well. I think that's probably, I'll hand back to Delphine.
You know, that's all we had for that presentation. We're still working through the different scenarios that we'll have over the next few weeks. It's all coming and happening, but we'll be working with Wong Sang and his team quite closely. Wong Sang, you may have something to add if you can talk.
Yeah, nothing much. So I'd like to highlight one thing is that our priority is always mentioned that we're going to quite interested in that what causes the rapid melting nearby the grounding zone. So the hollow drilling, and then also this AUV outcomes will be really beneficial and helpful to understand what's really going on here. So we're really looking forward to it. Thanks.
Thanks, Wong Sang.
And thanks, Delphine. I guess I'll open up to questions if there's any around.
More of a comment. I think it's great to see that we are sort of focused on the same areas, and I wonder if we can maybe try to set up some way of communicating when we are on our ships. In particular, I'm thinking about bathymetry data and stuff that we collect. If we can try to prepare, you know, ways of sharing so that we can use that when we plan missions.
Yeah, I agree, and I think it would be great if we could all, even pre-mission, to sort of see who is doing what, so that we don't duplicate and complement what everyone's doing, I think.
Yeah, and also the bathymetry that we have from 2019, we would be very happy to share with you if you want to use that for mission planning in the. So just let me know what kind of format you need the data in, and I can send that over. It's not much. We had some stability problems for one of the missions, so that data is not really nice, but the other one is okay. And you saw there aren't so many lines, but at least it's something.